Hello, this is Mrs. Scarple with video 2 of topic 2.13 part 2. In this video I'm going to go over how you solve the inequalities for logarithms and exponentials. And with this we use sign charts just like we did with polynomial inequalities and rational inequalities. But before we can get too far, we need to determine for which x values we can even do this with our logarithms. So, for example, we have the natural log of x squared plus x minus 5. But by definition, we know that this value has to be greater than 0. And x squared plus x minus 5 doesn't factor, so in order to find those zeros, I would either need to complete the square or use the quadratic formula. I am going to use the quadratic formula. So when I use the quadratic formula, I'm going to have x equals the opposite of b, and my b value is 1, so negative 1 plus or minus the square root of b squared, that would be 1 squared, minus 4 times the a value, which is 1, times the c value, which is negative 5, all over 2 times 1. Now, if I were to just leave it in its simplest radical form, that would give me negative 1 plus or minus the square root of 21, all of that over 2. But I need to use the decimal approximations because I can't tell you exactly where that's going to fit on a number line for a sign chart. So x could be approximately, when I evaluate negative 1 plus the square root of 21 over 2, I get 1.791. And when I do negative 1 minus the square root of 21 over 2, I get x is approximately negative 2.791. Now I'm going to take the time to I should identify my other one is when x plus 4 also has to be greater than 0, so x is going to have to be greater than negative 4. I will come back to determining which side of these two values we want to be on in a minute. For now, I'm going to write the inequality that we have here. So we have the natural log of x squared plus x minus 5 is going to be less than the natural log of x plus 4. I want to get my logarithm on one side, so that's going to be natural log of x squared plus x minus 5, and in order to move the natural log of x plus 4 to the left side, I would be subtracting it. So minus natural log of x plus 4 is going to leave us with less than 0. Using my properties, I can write this as a quotient, so natural log of x squared plus x minus 5 over x plus 4 is going to be less than 0. And now I can write my exponential form to eliminate the logarithm notation. That will become x squared plus x minus 5, all of that over x plus 4. The base of natural log is e, so we're going to have is less than e to the 0 power. Well, we know that e to the 0 power is actually 1. So I'm just going to put here equals 1 in parentheses. So now, in order to continue solving my inequality, what I'm going to do is I'm going to multiply both sides by x plus 4. That's going to leave me x squared plus x minus 5 is less than x plus 4 times 1 is x plus 4. And now I can move everything to the other side of my equation. and I'm going to have x squared, x minus x will cancel out, negative 5, I will end up subtracting 4, becomes a minus 9, is less than 0. So we're going to have x plus 3 times x minus 3, because this is the difference of squares, is going to be less than 0. So I know in my sign chart I'm going to have a positive 3, I'm going to have a negative 3, I'm going to have a negative 4. I'm also going to have these two values, 1.791 and negative 2.791. But I did mention I was going to come back and talk about which direction or which side of these values actually work in these inequalities. So if I take, let's just take the value of 1 and substitute it in for x squared plus x minus 5. I'm going to do this in a different color. So if I test it, I'm testing the x squared plus x minus 5, and I'm going to see if I get a value that is greater than 0. If I don't, then I know it's going to be everything less than 1.791. So let's put a 1 in, and that's going to be 1 squared plus 1 minus 5. So 1 squared is 1, plus 1 is 2, minus 5 is going to give me negative 3. So g of 1 is negative 3. Or I shouldn't say is negative 3. It would be the natural log. The natural log of all of this would give me the natural log of negative 3, which we cannot find. Let me write this a little bit better here. So we know that it's not going to be less than 1.79 because 1 is less than 1.79, and we can't find the natural log of negative 3. So we know that x is going to have to be greater than 1.79. Now I'm going to test this as well. I'm going to use negative 2 just to see if it works. If not, then I know I need to go less than negative 2.79. So I'm going to be testing it with that natural log again. I'm going to have negative 2 squared plus negative 2 minus 5. And that will give me the natural log of negative 2 squared is 4. 4 subtract 2 is 2. 2 subtract 5 is negative 3. Again, that's not going to work. G of negative 2 is not going to work, so I'm going to need to go less than in this case, because negative 2 is to the right of negative 2.79. I'm going to need to go less than negative 2.791. And the reason that's important is because there's going to be some values on my number line that I don't need to test because they can't work anyway. So we know that we have a negative 4 is a possible 0. We know that we have, and that it's got to be greater than negative 4 as well. So we're not going to use anything lower than negative 4. So it's got to be everything greater than negative 4. We've also got a negative 3 from our factoring here. We've got negative 2.791. We've got positive 1.791. And then we have a positive 3. So we need to check for intervals where we're going to end up with a negative value because we want it to be less than 0. But keep in mind we have to be less than negative 2.791, greater than 1.791. So I'm just going to mark on my number line, I'm just going to put some scribbles through that interval because we can't have any values within that interval anyway. So testing between negative 4 and negative 3, I'm going to put negative 3.5 into each of these expressions here at the x plus 3, x minus 3. So if I do negative 3.5, I'm going to have a negative times negative 3.5 minus 3 is going to be another negative. So that interval will be positive. Between negative 3 and negative 2.791, let's just say negative 2.9. Negative 2.9 plus 3 is going to be a positive, and negative 2.9 minus 3 is going to be a negative. So this next interval will be negative. It'll be less than. Then we can jump between 1.791 and 3. So let's just go ahead and use a 2. 2 plus 3 is positive. 2 minus 3 is negative. So there's another negative interval. And if I use 4, I'm going to have a positive times a positive, and I'm running out of room. Positive times positive is going to be a positive. So my solution to this will be that g of x is less than h of x when we're looking for those negative intervals. So negative 3, so from negative 3, x is less than, I'm going to use the exact form of this negative 2.791, which is negative 1 minus the square root of 21 over 2. But our other interval is from negative 1 plus the square root of 21 over 2. Give me some more room here. Is less than x is less than 3. So those are our intervals where we will have our inequality be less than 0, where it will be a negative. So again, it's going to be using sign charts. You need to find all the places where you're going to have zeros, and places, especially with logarithms, where you can't have the values. And that's why we ended up with this interval where values wouldn't work. And this concludes the video for topic 2.13, part 2, video 2.